Hi, everyone. Today we're going to talk about working with multiples of 10 and 100 and 1,000. We're going to look at some of the interesting patterns that occur with those numbers, and we're going to use that knowledge of those patterns to learn how to decompose, and we'll talk about what that talks about. We'll talk about what that means, different numbers, and really understand what numbers are made of. We're going to start with this word problem. It says architects make scale models of buildings before they build the real thing. The height of an actual building is going to be 1,200 feet. The scale model is 12 feet tall. How many times the height of the model is the height of the actual building? So let's think about what that means. We have a model that's 12 feet tall, and we have the actual building, which is 1,200 feet tall. Okay, so let's see if we can understand the relationship between these two quantities. So 1,200 is really made up of 12 hundreds, right? That's another name we can call it, 12 hundreds, or 12 times 100. So if we know that, then we can say, well, I know then that the actual building, right, is going to be 100 times bigger than the model. Now we're going to look at some more examples and talk about what it means to decompose numbers. So decomposing numbers means taking them apart into pieces to see what the quantity of that number is truly made up of. Like, how can we rename a number in different ways? Okay, and let's look at some examples, the best way to understand it. So we looked at 1,200. Another name for 1,200 is 1,200. And the reason that's the name is because it means exactly what it sounds like. It means 12 groups of 100, or 12 times 100. That means that these two ways here are just the same thing as this quantity here. We've renamed it. So 1,200 is the same as 1,200, is the same as 12 groups of 100, is the same as 12 times 100. Okay, here's another example. 930. 930 is the same as 93 tens. 93 tens, okay? 93 tens means 93 groups of 10, or 93 times 10. I think that's buried under there. You can't see that. Okay, so let's try that with some more, okay? This is 80. 80 is the same as, this one's kind of easy. 80 is the same as 8 tens. We know that. Or 8 groups of 10, or 8 times 10. 320 is the same as 32 tens, or 32 times 10. 90 is the same as 9 tens, or 9 times 10. And 890 is the same as 89 tens, or 89 times 10. 300, so there's different ways we can name this. 300 is the same as 3 hundreds, right? Or 3 groups of 100, 3 times 100. It's the same as 30 tens, or 30 times 10. Okay? And 7,000, we can look at the same way, is also the same as 7 thousands, of course, 7 times 1,000. 70 hundreds, or 70 times 100. Or 700 tens, or 700 times 10. These are different ways, okay, of saying this number here. We've just decomposed it to say, what is it really made up of, okay? 3,700 is the same as 37 hundreds. Oops, a little misprint there. That should be 37 times 100. Okay. Now let's look here. Let's try another word problem. It says John goes to the bank to cash a check for $990. If he wants his cash in all $10 bills, how many $10 bills can he get? Well, 990 is the same as 99 tens, or 99 times 10. So if it's the same as 99 tens, then John would get 99 $10 bills. Okay, so we know these things, right? We know how to divide and find these quantities, but it's important to stop and really kind of look at, what does that number mean, 990? Do I have to actually do the division? Do I have to actually divide 990 by 10 the long way? Or can I say, well, I know 990 is the same as 99 tens. So if it's the same as 99 tens, then he has to get $10 bills. Okay, so in today's assignment, you're going to practice on the worksheet looking at other ways to name numbers. Okay, so looking at other ways to call numbers. Okay, and this is going to help us kind of understand some of these patterns that are going to come up that we're going to continue to work with. Okay, so good luck with your work and have a wonderful day.